So today we are going to implement a tiny plugin for PyCharm, but nonetheless it's going to be useful. At least that's what I think. We are going to implement support for Flake comments. So you may know Flake, or you may use it to check your source code. And Flake is supporting comments to suppress warnings and errors. PyCharm is not yet handling that well, and we are going to implement that today. At least that's a promise, and let's see how well it's going to be. First of all, I will have to explain what we are going to do in a bit of more detail. So you will have to know what we will implement to follow along. After that, I will give a quick introduction to plugin development. It's possible to talk hours about that, but we can't do that today. So it's going to be quick, but I still hope that it's going to be useful for you. After that, we finally get to the implementation. I will show doing the development in IntelliJ. Today it's the community edition. You could do that in Ultimate as well, but you can't do that in PyCharm because it's written in Java. And at the end of this webinar, we will have a short conclusion with a quick outlook of what's possible. For example, about the possible improvements to this plugin, because a few things will still be missing at the end. But now let's get to the planning. And for this, I assume that you're not familiar with plugin development, but that you are a Python coder or developer. And myself, I'm usually only reading Python. I'm not writing it most of the time, but yeah, let's dive right in. First of all, we want to implement support for the no QA comments. On the first snippet, you see that that PyCharm is showing warnings in a place where it shouldn't, because this comment, the no QA on the highlighted line, is saying, oh, don't show that warning, but PyCharm is doing that anyway. And we want to hide that warning. It's expanded to see what it's saying. It's a warning about a locally unused variable. We don't want to have that. In the second snippet on this screen, you see a way how PyCharm is handling suppression of errors. In this case, it's the no inspection comment. It's a bit of different model used by PyCharm. It's usually above a line, above a function, or at the top of a file. So it's basically defined for part of the scope. Like everything inside of the function in this case will not show the error. But Flake is doing that a bit differently. And we definitely want to get rid of this no inspection marker so that there's no requirement anymore to add that. In the third snippet, you see what Flake is supporting. First of all, Flake is supporting a marker at the top of the line, which is saying Flake 8. When that prefix is available, any warning in that file will be suppressed and will be hidden. And Flake is doing prefix matching. At least I checked that with the current version. So you could add anything at the end of that comment and it will still be suppressed. And that marker can appear anywhere in the line. So even if it's on the last line of a file, any warning before that will still be hidden. And the last marker in this snippet is at the end of a line. And if a no QA marker is at the end of a line, it's hiding the warning for the current line only, so no other line is influenced by that. Keep that in mind. We are going to need it for the implementation, and I hope it's now a bit more clear what we are going to do. We'll basically support for the Flake marker anywhere on a single line or at the end of a line for the current line. And for that, if you think about it, we need a way to find out where's a comment on the current line, if it's is it before a line feed or not. And we need a way to look into the file to find any comment which is somewhere on the file. Of course, you could do that with text matching or any other way, but we will do that with the built-in functionality of PyCharm. And we will get to that feature or to that feature set we will look into on the next slides. For that, I will need to tell you a bit about the basics of plugins. That's going to be very short. After that, it will get to be a bit more technical. It's going to be about that PSI. I will tell you what this is in a minute. After that, I will quickly explain what inspections are. You probably have met them already in PyCharm because there are lots of it, lots of useful inspections. And I will tell you about the place we will plug into. So a plugin is plugging into something, and there are many places where this is possible, and we just need one to suppress the annotations to support the flake markers. So now let's get to the basics. First of all, on the left side, you see the PyCharm logo and a box around that. All of that is included when you download it. So there's a set of core features, which is the SDK, and a set of plugins which come shipped with a download on top of that SDK. Plugins can be disabled, but bundled plugins can't be uninstalled, so you can only disable them, and you can choose any plugin you like. You will already know that. There are lots of plugins, especially in the Pro edition, which are very useful. In this case, for example, the JavaScript and Python profiler plugins are part of the Pro edition. The Git plugin is coming only in the Community edition, and there are some more. On top of that, you may install any number of custom plugins from the public repository. In this case, for example, MyPy, the PyLint plugin, or the Black plugin. These are extensions which are useful for Python development, mostly around linting and formatting, but there don't seem to be a lot of other plugins intended for the PyCharm environment. And the plugin itself is usually just a zip file. That zip file contains a few other files like that plugin XML file. That's a very central piece of a plugin because it defines the unique ID of a plugin. It contains the description, basically everything you see in the plugin manager inside of PyCharm. It contains a logo and all the places which are made available by the plugin. Places is like a feature. The plugin provides a set of customizations or new features which will be made available in PyCharm. And of course, you will need some code as well. You may write that code in Java, but if you prefer, you can use any other language which is running on the Java virtual machine. For example, Kotlin, which is already shipped with a base SDK, so it's easier to use it. But if you prefer, you can use any other language like Scala or Groovy if you want to. That's a bit more difficult to set up, manageable, but a bit more setup to do, and it's definitely increasing the download size. So usually I stick with Kotlin and Java. You may include any other data in the zip file, like images or binaries you want to run on the different platforms or operating systems you're supporting. And that plugin is uploaded to the public repository and made available for all the users of PyCharm, which can then either download the plugin on the plugin repository site at plugin.jetbrains.com or using the built-in plugin manager. That's all for the very basics, so that you need to know. That's basically just a bundle of metadata, code, and assets. and installed into any of the IDEs, in this case, PyCharm. You may wonder about a way how to access the structure of a file. Like when you need to find out where a comment is, you need a way to analyze that file. If you were writing an IDE on your own, you would usually write a parser, which takes a Python file, parses that file, and provides abstract syntax tree to analyze. I will demonstrate that in a short example, and definitely you don't have to write all of that on your own, because PyCharm is coming with a lot of functionality built in, and so the parser is already included in PyCharm, and any other language support in the IDE is usually also bundling Alexa and a parser, and a lot of classes on top of that to simplify working with that structure of a file. In this case, I'm showing a very small source file, just a simple function definition called hello here, and PyCharm is first running Alexa on that, basically to create a sequence of text-based tokens for that single file, and that's going to be needed in the next step. And all of that is part of that PSI layer, which is short for Program Structure Interface. And that's a very central piece inside of the IDE, and you will always get in touch with that, or usually if you write something around languages, you will definitely meet the PSI layer when you dive into plugin development. So now we have a sequence of tokens produced by the Alexa, and that somehow has to be turned into a structure, and that is what a parser is doing. So basically the parser takes a sequence of tokens and creates a tree or a structure from that. And I'm showing that result, which is produced by the Python parser. So you can see that we have that function hello with a name, and that is split into several pieces. So basically, as a human, you know, if a line starts with a def keyword, when there's white space after that, then a name and parentheses with optional names in between, followed by a colon. That's up to here, followed by a line feed and white space. Oh, then it's going to be a function definition. And that knowledge is, of course, also made available in the parser. And that parser creates a structure from these tokens. And first, it's creating a function which covers all of the tokens above. It's a Py function. That's the internal name of that function. We are going to need it in the next step when we get to the implementation. So I hope that it's understandable. If there are any questions on that, feel free to ask. The def here is part of the original sequence that's retained in the syntax tree. It's the def keyword, then the hello name. The next part is passed as a parameter list. Starts with a token with the opening parenthesis. Then comes a structure element for the name parameter, and inside of that is the token name and the closing parenthesis and the colon. And after that comes a sequence of statements or list of statements. That's how it's called internally in PyCharm. And the only element in that list is an assignment statement. So assignment statement has a left side and the right side, but basically you just need to know that this Py assignment statement has a left side, which is n, has a right side, which is another expression, which also includes the no QA marker. And that marker is, of course, then also included in the assignment statement. And all of that is, as mentioned before, is building the Py statement list with just a single element. List tree is made available by PyCharm, so it's handled in a very efficient way so that the plugins don't have to do that on their own, and it's only done when necessary, so there's no unnecessary work being done in the background. The PSI layer provides a lot more functionality on top. For example, you could ask the function, the Py function, that's a class in Java, and there's an object for that. You could ask the function, oh, tell me your name, and it will return a hello string. You could ask that Py function for the list of the Py statements, and it will return the Py statement list. So that's a very good or high-level abstraction to work with files. That's all I think we need to know about the basic layer. And you may wonder where these warnings come from. You see that that PyCharm is adding a warning in this place. It's saying, oh, here the variable n is unused. That's the result of an inspection. You can turn inspections on and off, and there's a setup or configuration dialog in the settings to handle inspections. There are some more which are not enabled by default, but this one is. So usually most of the warnings you see are produced by inspections, and this one is, as mentioned before, also made by an inspection, and we want to have a way to get rid of this. And an inspection is basically just an extension which is implemented by a plugin, and is basically just a message with a highlighting type and optional quick fixes. The message is just the string, like the local variable n value is not used. That's the message of this inspection, or the message produced by this inspection, and the highlighting type can be error or warning or like an unused element. And it's, in this case, it's an unused element because the highlighting was modified by the inspection, and that's why it looks slightly gray or light gray, and that's based on the highlighting type. The quick fixes can be provided by the inspection as well. You see that in the second screenshot, or in the second snippet. Remove statement is a quick fix to get rid of the warning. You could just remove the unused variable, and that's made by that quick fix. It's important to remember that inspections have a unique ID, so we will need that unique ID in the implementation. And it's important to know that there is such a thing. Right here, I would like to hand over to Paul, because the next step is going to be the implementation, and this is already part of that. So Paul, are there any questions?
Sure, we've answered a few, but a couple that I want to pass to you now, and then a couple later once you start showing some code. The first one for now, how much of plugin development is common between the IDEs?
That's a good question. There's a lot of functionality shared between the different IDEs. For example, PyCharm is basically a repackaged IntelliJ with disabled Java support and the Python support built in. So there's a core set of core features which is available in every plugin, in every IDE, and on top of that is usually some more functionality which is usually available also for the IntelliJ community and Ultimate editions as a plugin. For example, the IntelliJ community has a Python plugin, and that same functionality is also included in PyCharm. But there's, my guess is that about 80% is shared between the different IDEs, and the different IDEs have their own code on top, but that is also available as a plugin. So you usually don't have to duplicate or re-implement if you target different IDEs.
Right, and one of the things I was thinking on this question is I hear that preferences or settings, that all that machinery is really rich, but also can be a lot of coding. And the preferences system is the same between all the IDEs. Once you learn it, you've learned it for all the IDEs, right?
Yeah, that's right. The interface is usually just the same between the different IDEs, and the plugins have places to plug into to extend the settings, for example. So you don't re-implement your settings dialog, you just plug into it to add a new item to this list, for example.
The second one is harder, and I'm not sure how much you are deep on Python. Could you go back 2 slides to the part where you were parsing the function?
Sure. This one?
Yep. So the question, I believe it's about this slide, is how does PSI handle grammar differences between different Python versions? For example, later versions of Python 3 can have variable annotations on the name argument, for example.
Yeah, that's a good question. The same applies to other languages like Java, where there's a lot of differences between the different versions. I think there are different ways to implement this. Usually it's there's something called the language dialect, which is basically a configuration for the parser to tell the parser, oh, now only parse a file syntax of Python 2, or you could tell the parser, oh, parse Python 3. And so there's a difference if you handle it that way. And another way is to highlight errors after the parsing was done, like for example, if you use something from Python 3 or later versions, which is not supported in earlier versions, you could implement something called an annotator to highlight that piece of code as an error if you see that the user is using Python 2, for example. So there are different layers of implementations which are possible here, depending on the difference you are looking for or looking at.
Makes sense. We'll save the other 2 questions for once you start coding.
All right. Should I go on?
Yep, sounds good.
All right. You might be wondering, how do I tell PyCharm to suppress that particular error or warning? And here we come to something called an extension point. I have told you about that plugin XML file. I will be showing that later on in the IDE. That plugin XML file just is metadata and contains a list of things which come with your plugin. And in that plugin XML file, you will tell PyCharm, hey, I would like to implement something called an inspection suppressor, and here's my class for that. This is the Java interface, how that extension point is looking like, and that is defining what we need to implement to tell PyCharm to suppress the errors. So basically, there's a long list of extension points, and a plugin can choose any one of these extension points and add an implementation for that. And this will be read by PyCharm when it's starting, and it will be integrated into the IDE with the features that it's supporting. So let me quickly tell you what we are going to do. At first, we are going to add tests to make sure that we are not writing something else, and to make sure that our code is doing what we want it to do. After that, we will implement that extension point I was just telling you about, and after that, we will run and show that plugin in PyCharm. I hope that everything is going to work. So now, here's there was something missing. It doesn't matter. Now we are going to switch over to IntelliJ. Let me just show what's going on here. This one is the plugin XML file. It's basically an XML file with just with a defined structure. It starts with the IDE plugin idea. Plugin tag defines the unique ID of a plugin and more metadata like a name, which is a name you can change later on, a version, my vendor information, and a description. And it also tells the IDE that it needs the Python core module to either tell IntelliJ that it needs the Python plugin, or to tell the PyCharm IDE that it's needing the Python code. So you can't run that plugin on PHP Storm, for example. And that's what we want. And after that comes a tag to define the compatible versions you're running with. So we are only supporting 1.8.3, which is the latest version as of last year. And after that comes a list of possible extensions. I've already added a note, a commented line here, which is showing what we want to implement. But let me quickly tell you, show you what other options are available. For example, you can use code completion to see what's available, and all of these are extension points. So a plugin can plug into any one of this and implement that. So this is a very long list. And if you just scroll through that, you see a lot of things which I don't even know. So there's a long list of possible features, and when you're looking for something, you usually go through that list to find a matching extension point. And I had to do the same to find the inspection suppressor. So there's a lot for the compiler, for the configuration, for coverage, reporting, etc. So keep that in mind. You can use autocompletion to find out what's available, and at some point you will find out that there's a language suppressor to implement. Right now, I'm going to start the implementation. I'm now going to create that class. I don't want to use, don't want to see all of that again. We need to implement two methods, and this is just the empty implementation, and that's able to compile, but it's not doing anything, because that is suppressed for method is just saying, oh, do not suppress any warning or error. If we return true, then every warning would be suppressed. We don't want to do that. We just want to do that for Python inspections. And we only want to do that when that comment is present in the file or on the line. The inspection is passed in as an unique ID. Inspections have unique IDs as well, and this is the tool ID you are seeing here. Let's create a test first. I'm going to create that test. There are a few things you may need to know about the test framework. There are a lot of different base classes, some older, some newer, but the best base class I'm using is usually something called the light platform test case, and there are different variants of that. And this one is the one I'm using. That's for JUnit 4, which is a unit testing framework for Java. And we're going to use this one. Let's just write that code. And we want to implement a test method, just a simple one. At first, we want to make sure that we are suppressing errors. So let's write that test method. JUnit needs annotations to mark methods as testable. So at first, you need to know that inspections are all disabled by default in tests. So we have to go the extra mile here and we have to enable all Python inspections. That's a bit more than you usually need, but we are going to enable all Python inspections to make sure that we are not missing anything. This is a bit of a deep dive into the internals, so more of the usually not used things of the SDK, but that happens, of course, from time to time. There's the inspections are available at runtime, so you can access the inspections, and that is available at the local inspection extension point. EP stands for extension point. We are only going to look at the local inspections. Global inspections are a bit different because they can be used in batch mode, but that's not what we are looking at this at this time. Might be a possible extension. So this is that is Java talk. That is a stream, basically a list which can be transformed and filtered. We need to turn the configurations into the actual objects. So we need to instantiate these first. This is done with the method instantiate tool, which is available at that inspection extension point. And as I said, we want to enable all Python inspections. So let's do that. Every inspection has a short name, which is the unique ID here. And if it starts with a PyY, then it's a Python inspection. I find that out by looking at the plugin XML file of the PyCharm distribution. But yeah, you could do the same if you want to. These are all the Python inspections there are. So, and we want to have that as an array. Let's see what an E is. It's an inspection profile entry, and we want to have an inspection profile entry array. And we can get a reference. We can get an array from that and turn that into a variable. On the side, the inspections we want to enable. We still have to tell the testing environment to enable these inspections. This is the enable inspections method. We're calling that with a variable we just set. So at this point, all the inspections are set at runtime for this particular test, and this test is being run in an headless environment where all functionality of PyCharm and IntelliJ in this case is available. So now let's create a dummy file with some dummy code and make sure that no inspections or errors are shown. Let's do that. The fixture is the thing we usually use to talk to the headless IDE. And there's a configure by text method, which first takes a file name of, and after that, it takes the content. So this one is the content parameter, and what I usually do is that I inject Python into that string so that I can just in the window below, you see a Python editor, and it's automatically put into the string in the Java code. That's part of the IntelliJ plugin. It's very useful. So let's define a very simple function with an unused variable and no QA marker at the end. And let's close it. And this is a piece of code which should not show an error when our implementation is working well. And there's also a way to make sure that no errors are shown. The check highlighting checks the content for error markers, and if it's not as expected, it throws an exception. And in this case, we say that we do not expect any errors, and if that check highlighting method is failing, then our implementation is wrong. And we could run that test now to see what it's doing. Let's do that. Takes a while. It's Java after all. Okay, that is an issue I usually would not have. Sorry about that. That has to do with a sandbox because I was already deploying that plugin. I'm not sure what's going on here. That should have happened. I'm sorry about that. Let's do that again and hope that it's working well this time. Okay, this is not expected. That I'm sorry. I'm not sure what's going on, but let's look into this to see how to debug that in real time. Might take a bit more time, but useful nonetheless. So this one is the SDK we are using that's set up with the Python plugin. This is all the jar files which are available in that source code. And okay, somehow I did not manage to include the plugin in that setup because you may have noticed in the original GitHub repository I shared with the setup instructions that you need to set up your environment to use the Python plugin as a dependency. I think I just removed the checkout before the webinar, so the language libraries are not available here, so we need to do that right now. Let's do that. Sorry about that. I have downloaded that as this file. We're going to need this one, and we need to put this at the location where my Git repository is living. So I have a user webinar. That one here contains my checkout. I'm just putting the files there, and after that I will have to add this to the SDK setup. That's something usually do only once, because the setup is a bit more complex, especially when third-party plugins are involved. It's possible to do the same automatically with the Gradle build tool if you do not use third-party plugin dependencies. But this time it's a bit more manual setup. Should be over in a few moments. Okay. We should have now the plugin files of the Python plugin on disk. It's right in here. We need to add all the different libraries, this one. And you can see that all these libraries of the Python plugin are now attached to the IntelliJ SDK. Give it a minute to pass the files, and now let's try again. Okay, that's looking better. It was compiling because we were not yet using any classes contained in the Python plugin. That's now how it's supposed to look like. The test is failing, of course, because we have not yet implemented anything. And you see that what we have on the left is expected, anything without warnings, and on the right, you can see that IntelliJ includes warnings inside of the output. So inspections, which you usually see in the editor, are shown as XML tags in the output of the check highlighting call. So let me quickly show that again. Here's some inspections which are a result of the setup, like no encoding specified for file or no Python interpreter configured. We want to get rid of these warnings for the test case only because that's usually not happening in the production environment, and it's hard to set up in the test environment. So I've prepared a short list of inspection ideas we are going to ignore. So we are not enabling these. So I need to ignore a few more. So basically, we have a set of strings which contains everything we want to ignore. So there's a short set of excluded inspection IDs, and we want to do that. So I'm going to use the new hash set method from Google Commons, this one. I've prepared a short list because I can't remember these names. This one is a list of three inspection IDs we want to ignore. I'm going to add this one right here. And we want to make sure that the list of excluded is not containing our ID of the inspection we are looking at this point. Let's run it, see what it's doing. There should only be one error left in the output, and that's what we're expecting and going to suppress in our implementation. Let's check that. Of course, I had this wrong. Filter means to keep an element, it must not be excluded. It must not be contained in the list. Let's see if that was correct. Okay. Right now we only see one warning left, which is our local variable values unused. That's the one we were expecting, and that's the thing we will remove when we implement the extension point. So I'm switching now back to the implementation, but first of all, I would like to hand over to you, Paul, to ask a few more questions.
Okay, good. Let's see, I've got two. I'll start with the second one because I think it's more appropriate for the point that you're at right now. What is the debugging process like? Do you use the debugger, or do you just log things to the console?
Okay. When I'm writing test, I usually run the test to see what it's doing, and if it's clear to me what the output indicates, then I usually stick to the run console, to the run configurations. I just run it, and let me show that. So I usually run it, but if I can't find out what's going on, and if I can't see the point of error when I'm looking at the source code, I'm usually debugging. So oh, sorry, let me turn off that no distraction mode. So right here I'm setting a breakpoint, and I can use the debugger to look at things. If I really want to, I only do that when necessary, but it's possible to just debug that, and you can step over, for example, to get to your next point. Right here, you can see what inspections are included. These are 76, etc. So there's a lot of inspections. So yeah, I usually just use it to find out more when I can't use the test.
Right. Okay. The second one, what kind of performance issues? And I think I'm interpreting the question correctly. What kind of performance issues do you have to consider when writing something against against an inspection plugin, extension point, etc.?
Yeah, that depends how often that extension is used. In our case, that inspection suppressor is used a lot, because for every single error there is in the file, it's called for every inspections. So to just check a single error, it's called 76 times. at least 76 times because there are at least 76 Python inspections. So it's called a lot, and we have to make sure that it's not slowing down. So we have to avoid as much work as possible in this implementation. But there are things like other extensions which are only called once. But if you want to implement a good performance, then you usually have to look at the usages of the extension point, for example.
All right, I think that's exactly the kind of answer they were looking for. All right, so those are the two questions I have.
All right, let's go on. Let me get back to that Java file. So now we're finally getting to the real part of the implementation. We have a very basic test in place. We can extend that later on. At first, as just mentioned in my reply to that question, we have to make sure that we are not doing any extra work. So the best is to return as quick as possible if you see that we are not handling an error of a Python inspection. So if the tool ID is not starting with a PyY, it's not an inspection related to the Python functionality, something else, and we do not want to handle that. In this case, we just tell PyCharm, oh, do not suppress that error. And at this point, we have to look at the structure of the file to find out if there's a comment at the end of the current line or somewhere in the file. So that means that we will need a way to find out is the element suppressed by end of line. Just writing longer names here to have so that you can see what's going on. We pass in the element, and we are going to sorry, German keyboard. And we are going to have a method to find out if it's suppressed by a line comment. So let's write that. We pass in the element, and we're going to implement these methods now. Using a quick fix to do that. We have the element, and if you remember that sequence of tokens I have listed, all of these yellow elements highlighted in yellow on the slides are leaf elements, which means they do not have any structure below it. So we only want to look at these because we know that a comment at the end of a line is included in this list. So we need to iterate the list of leaves, which is to iterate only the yellow highlighted elements on the slides. We will have to keep the leaf in memory. We are starting with the first leaf right after the current element. The first element is the marker element. So if you the element passed into this method is the element containing the marker or the error marker, and we can be sure that the end of line comment has to be after that. There's a utility class in IntelliJ to work with a PSI structure. So we will look at the next leaf after the element. We do that as long as the leaf is still valid, and at the end we replace it with the next leaf after that. We are using the utility class again, and it's going to be the leaf after the first leaf. Let me remove this so you can see that better. If the current leaf is a white space which contains a new line, so new line is contained in white space tokens here. If that is a white space token which contains a new line character, then we can be sure that we have to return early because we are not skipping the warning on the current line because there's no comment when we reach the end of the line. So this one, the leaf, is a PSI element, and there's a method on every PSI element to find out if the text contained by that leaf, in this case, for example, the identifiers or the equal sign, etc., and the white space is containing a new line character. If that happens, then we know that we are not suppressing the error and return false. But if that element is a C comment, and if it's fulfilling our requirement that the text contains the comment marker, then we can return early and can return that we want to suppress that. In this case, we just return true, because in this case we say, oh, if that, if that element is a C comment and the text content attached to that leaf element starts with a no QA prefix, then we know that we can suppress that. In every other case, for example, when the end of a file is reached, we can safely assume that we are not suppressing anything else. Now let's get back to the first method and implement the method to check the lines on the current file. This is the empty implementation. It does nothing. This one should be sufficient for our current test case. So let's just run it and see how well it's doing. Because this test is only using the end of line marker, and it should be sufficient what we implemented. Let's see if that's working out. Java is slow, as you see, or my machine is slow. As you can see, that was not sufficient. I have managed to do something wrong here. Again, I have not negated that condition. If the ID of the inspection is not starting with a PyY, then it's not a Python inspection and we need to return early. And hopefully this is the only bug I introduced. Let's run it again and see what it's doing. Okay, now the test is passing what was failing before. So this is so far a sufficient implementation for the first test we had. Now let's write the test, the code for the single line markers, but let's get back to the test first and add the test case for that to be sure that we are writing a correct implementation. I will reuse this code. So let's extract the method, call it this way, and let's extract this value as a parameter, which is the code. And I still want to retain that highlighting, and there's a little trick if you want to do that. So if you have the language comment in front of that, and after that the language ID, then automatically the next string on the line is injected with a Python language. In this case, I could have used any other language. That should also work in other file types as well. I want to reuse this and just add our test for the error marker on top of the file. So here's the flake 8 marker with a no QA, and we are going to remove this one at the end of the line. Let's close the editor and turn this into a single string without concatenations. And when we run this test, it has to fail because we have not yet implemented the support for that. Right, that is what I expected. The second one is failing, and there's still the warning about the local variable. And we are going to switch back to our class and implement that method. So as I mentioned, we have to look at the complete file to see if there's any line comment in there at any place. It's best to be performance to have a good look at the performance, but right now for this sample implementation, I'm going to use a bit slower method, and I will optimize that before the plugin is released. We start with an on top of the file. So every element in the PSI layer has a get file method, get containing file to access the file. So that's basically the top of the PSI structure for the current file. The file has directories, etc. on top, but we don't have to look at that. And we want to basically visit every element in the file to find out if it's a line marker or not. So let's do that. There's some concept of a visitor, which basically calls a method for every element of a certain type in that file. And that's accessible via the accept children method. We want to do that recursively. If a single call to accept children just is visiting the top level children elements of a file only, but we want to do that for the whole tree. So we want to visit the grandchildren, etc. And for that, we have to use a recursive element visitor. As you can see, there are several methods to implement, but we only want to visit comments. I could do that to visit directories, files, white space, foreign elements, but I only want to do that for comments. In this case, if the comment is containing that marker, so if the text starts with a flag 8 no QA, then we know that we need to suppress this. And here comes Java into play, because it's a bit complicated to do that inside of an anonymous class. So I have to do a bit of workaround, and I will just do that. So I will need an array of a Boolean to find out if it was found or not. We default to false. In this case, we know that the element was found. I have to use an array as a workaround because otherwise only final values may be used. And the found value is now true. And here we are going to return the value we were computing. So basically this one is visiting the top level elements of the file, and the recursive visitor is defining that every child element of these elements are visited also, and every comment which is located on the way is checked by this check if it's matching our comment line. And this method we were implementing is called by the main method we have in that extension point, and right here it should be working. Let me have a quick look at that. Should be fine. Let's switch back to the test and run the test again. And this time, at least, I did not manage to include any bug or issue in my code. And so right now the test is passing. And this means that we managed to implement support for the no QA markers in the plugin. That's a very small plugin. And to have production ready code, I would include more tests. In this case, for example, to make sure that we are not suppressing more than we wanted to. So we may not suppress inspections which are not part of the Python package, for example, and we may not suppress errors in different file types. So we may not hide errors in Java files or in plain text or JSON files. We may not do that. And for that, it's also possible to add a few tests. I will do that after the webinar, but I think the time is too short to do that. Let's have a quick glance at what we have written. So basically, we have our inspection suppressor. This is the interface which belongs to the extension point. This is the method called by PyCharm for every highlighting added by an inspection. And we need to be quick. Therefore, we are returning early. And there are two types of checks we are doing: end of line and suppressed by line comment anywhere in the file. That should be sufficient. And before I hand over to Paul for a set of questions, let's run it in PyCharm. That should be working well if I use the run configuration. That's the one prepared in my base setup. Let's run it in a debugger to be able to step into when we want to look at something in detail, but that shouldn't be necessary. I need the initial setup. Let's just skip that. The first setup, the first run we are doing now is not going to be successful because the Python plugin is not included. So the SDK setup is not sufficient for that. We need to install the Python plugin as well in a sample project. I should have a sample project somewhere. Let me look at that. This one. It's loading it by the Python plugin is not yet installed because it's IntelliJ. You could, of course, package the plugin and run it in PyCharm as well. That's also possible in an automated way from the command line. But that's something else we could do. So we need the Python plugin. This is the community edition, so we need the community edition plugin. That's for the test setup. So this is a completely different setup compared to the one I was working in for the development. That's running in the sandbox. So different settings, different plugins, everything is different here. There's a bug. I need to disable that plugin to make sure that it's shutting down. Let's do that and let's restart it. Takes a while. Here it is. Let's add a sample file. And let's write some code like you see that the error is still shown. There's no marker yet. No Python interpreter configured is the same warning as we have seen in our test. I'm disabling that. My Python setup on this Windows machine is not complete. If we want to get rid of this warning, we will add that no QA marker in the end. It takes a bit until IntelliJ sees that the noQA marker is present, but right now you're seeing the plugin we just wrote is in action. I just added that marker, and a bit after that, PyCharm, or IntelliJ in this case, removed the error marker. If I'm now writing a different comment, you see that immediately after that, the error is back in. So you see the little gray marker here. And if I add the marker back in, then there's no error marker here on that location. That was done by our plugin. Let's just validate that the global marker is working as well. We already did that in our test case, but just for demonstration, let's do this as well here. I added the flake marker, and as mentioned, it may take a bit of time until that one is ready. So if you, for example, added something at the beginning of the file, then it's usually not that quick to update things at the end of the file. But if you open up a file, that should be done at first time you open up. So when you're editing, it may be a bit slow, but you see that here the marker is also not present anymore, and we do not need the no inspection marker. You need it until this point, which is PyCharm's workaround or PyCharm's way of suppressing. And you see that a very small plugin is still useful, even if it's just a few lines of code. And I hope that this demonstration was useful to see what's possible, or at least to see a very tiny part of what's possible. There's a lot more. And now, Paul, I would like to hand over back to you for further questions.
All right. First, that was really cool. saying that at the end was really good. 3 questions. One of them, I think I know the answer to, but I'll let you answer anyway. At the end, when you were going back and forth between removing some characters from the marker and putting them back in, did you have to save the file for the inspection to rerun, or is it all part of the virtual file system?
I do not need to save, so I did not do that. Inspections are rerun after the cursor or your change is settled. So when you're typing, the inspections are usually not run, but I think it's a couple of 100 milliseconds. And after that time, when you stopped working in that file, PyCharm is rerunning the inspections, and in our case also triggering our inspection suppression endpoint. So you do not need to save, you just need to wait for a bit or to stop typing for a bit.
Mm-hmm. Okay, the second one's kind of very broad, so feel free to just give a very short response. Is an intention much more work? So instead of having to type the suppression marker, you alt-enter on it and get a automated.
I didn't get that question, I guess. Could you
Sorry.
say it again?
Right now, the inspection tells you that you have that warning, and you fix it by manually typing a comment at the end of the file, at the end of the line. An intention would let you put your cursor on it, hit Alt-Enter, and let the IDE fix it. Is writing an intention roughly the same amount of work?
So there's a bit of overlap between inspections. That's the one we were looking at, and intentions. So basically, inspections. There's an overlap between both, and intentions are like quick fixes for inspections. So let me show you the outlook of what's possible after this. Right now, you see here the remove statement, which is the quick fix to get rid of the warning. There's no warning yet, and here's a way to suppress, to add error markers automatically for that quick fix using our inspection and our extension point. So there was another method which we did not implement yet, which is this one. So get suppress actions is a way for me to provide more suppression items. So if I added an item to this return value, then I could add this point. I already did that in a sandbox plugin, so it's quite easily possible to add another item to the quick fix options. And if you just press enter here, the comment will automatically be inserted. But if you wanted, in this case, it shouldn't be possible to use an intention, because the intention wouldn't know if the error was suppressed by this extension point or not. Of course, you could share some code, but I think this way is easier to implement and more easily to understand when you're using it.
Right. Again, the last one, I'm going to generalize what the question was a little bit. You do plugins for customers, right?
I do, yeah.
And just as an editorial comment, your customers are very happy with you because they wrote back to tell me, thank you for, they thanked us for recommending you to them.
Oh, that's good to hear.
And so for people who are watching this and saying, okay, now I kind of understand it, but I don't have enough time to learn the SDK, and we need help. So getting back to what the question was, your commercial plugins, how much other kinds of work is there to do for something that could be uploaded into the store or into the repos and installed as a quality plugin?
Of course, that depends a lot on the feature set you want to implement. If we wanted to publish this plugin, I would have to add a proper website to add documentation, how to maintain this plugin and how to upload this if the customer wants to do that on his own. Plugins for customers are usually larger than this one, of course. There are maybe smaller ones, but they still will be larger than this one. And I usually try to add a lot of test coverage to make sure that it's working with versions released in the future, and also a good set of documentation. So the customer might need to maintain the plugin after the actual development was finished. So yeah, depending on the feature set, it's can be a bit of more work or a lot of more work. For example, if you're adding a custom language, then it's a huge amount, or a large amount of work, because that's a very complex thing to work on.
Right. I remember in your interview, that was one of the things, and you actually enjoyed that project, right?
Yeah, that was a fun, that Tezos project was fun, but it's a lot of work, because you need to write Alexa and the parser, you need to define a grammar, and you need to implement code completions, documentation lookup, integration with the command line, with the network, etc. So depending on the feature set the customer's looking for, it can be just a bit of work, a very small plugin. I already did that as well, just tiny or smaller plugins, maybe to just sync a few files on save, or if you want to do a custom language, then it's quite a big chunk of more work.
Are there pieces like preferences or other parts that really add to the work it takes to ship something?
It's usually,
I guess it depends on what the features are.
Yeah, sure. Usually, there's a lot of fine-grained extension points. So if you just want to proceed incrementally, then you just implement extension point for extension point and release a version after that. So adding to the preference is a small part, adding code completions is another part, and it's always possible to release a version or to stop working at that point when you just do extension point for extension point. So the way of defining or declaring extensions in your plugin is a good way to work incrementally, because you do not need to write a huge class which does everything at once.
Good point. All right, that was the last question. Do you have any more that you need to finish up in your slides?
Just a quick talk about the possible improvements and a quick conclusion. So first of all, it's would be good to add no QA to the dictionary, because every PyCharm instance will tell you that it doesn't know a no QA, and it's possible for a plugin to provide a custom dictionary. That's easy to add, very easy to add. So I'm open to pull requests here as soon as the plugin is online. If you want to dig into doing that on your own. There's a further feature supported by Flake to suppress only certain errors using the markers. So there's a form of the marker which is defining the error IDs to suppress, and I have not done that yet because it needs a mapping of the error IDs provided by Flake and the inspection IDs provided by PyCharm. So if we had a mapping of those, then it was rather easy to implement that, but that's an additional feature still possible. But I think the no QA marker, what we have right now, is the most useful. And if we needed finer grain control over the suppression, then this is the thing to add. And as I mentioned before, it's also possible to add a custom suppress action. So you don't need to write that comment all the time. You just need to press enter on the quick fix option shown in the snippet. And that's a quick way to get rid of the warning and of the typing at the same time. And you could also add another suppress action to add the Flake line comment at the first line of the file, for example. That's also easy to add. A few questions and remarks were already answered. I think that should be all for now. So from my side, thank you very much for listening and for staying in that webinar. It was fun for me to do, and I hope that it was useful for you to listen and to see what's going on. If you have any feedback afterwards, for example, if you watch the recording later on, or if you found the slides online, I'd be happy to hear from you. Just head over to my website and post a question in the contact form, or open a pull request with that plugin in that Git repository I'm going to release afterwards. Thank you.
I got to say, you came on almost completely on time. If it wasn't for my, you would have been perfect, and really covered a tremendous amount of material. So thank you very much for doing this. And for everyone out there who looks at this and says, that's good for my company, you really should consider doing some consulting with Joachim, because it'll get you started very quickly. And as he makes the case in his interview, the amount of productivity, and actually maybe you could comment on this a little bit, the amount of productivity that can be gained by speeding up one little thing that your team does hundreds of times a year can easily pay for the expense of a plugin. Do you want to talk about that a little bit?
Sure. That's the thing I'm selling. That's the thing I'm offering. I think there's probably a very good reason why you are using PyCharm in your company or at home. And that's mostly, I think, because it's a very useful product. It's a very great software implemented, and it's smart, and it's saving a lot of time, because you can do refactorings, you can do searches for methods, etc., in a very much quicker than before, if you were doing that in a text-based editor or on the command line or somewhere else. So there's a lot which is already coming with PyCharm, but if you are in a company, for example, with a custom software, or when you're working on certain file types which are not yet supported by PyCharm, then it's either a lot of work and a lot of hassle to do that, or you should try to make that as smart as PyCharm is handling the rest of the environment, and that's where my work is coming in. So I'm basically offering to bring the support PyCharm is offering for Python and the basic set of features for your custom environment or your special environment you're working with. And as you already mentioned, Paul, even saving a minute a day for a developer, if you have 20 of them, and over a year, it easily adds up if it's just a minute. Or I guess it's usually much more than that. And if you do the numbers, you will see that a lot of time is spent on things which could be handled in a better way or in a more automated way. Of course, it needs to be a balanced decision. If you're spending a lot of money on a very small optimization when there are other things to optimize first, then of course don't do that. Or if you run a small company where you do not have that budget yet, but I think at least for larger companies with more than a few developers, it's usually a good decision to try to get the best tooling out there.
And it's not just a productivity thing, it's also a quality thing. All of those little tiny workflows are an opportunity to ship a bug.
That's right.
And what you said about large companies, we meet with some large companies that have in-house teams writing plugins for PyCharm and our other IDEs to automate internal workflows. It's really impressive to see what some of them are doing, but they're big companies that can hire an internal team. Other companies should go to you.
Yeah, that's a good way to handle that. Yep. I'm happy to talk about any idea you have about possible projects.
Yep. All right, so to go ahead and wrap up, if any of you have any questions later, please don't hesitate to reach out to us by email or social media. If you'd like to get more information on PyCharm, please go to our website at jetbrains.com/PyCharm. We'd love your feedback on this webinar, so please feel free to contact us on Twitter or especially in the after webinar survey. We read that. Please fill in any ideas that you have about what we could do better or ideas for webinars in the future. We use that for planning. And as a reminder, the recording will be made available on our YouTube channel soon. We'll let you know on our blog where you can find up-to-date PyCharm news about releases and events. Pay attention to our blog. Lots of good stuff is coming, as well as educational resources about other aspects of PyCharm. So, for example, this recording of this webinar will be published on the blog and on Twitter in the coming days. We'll also provide some additional links and information from the presentation on the blog, including the link to the repo that was shown today. That's all for us today. Thank you very much for joining us and hope you have a nice day.